Hello and welcome to C++ Weekly. I'm your host, Jason Turner, available for code reviews and on-site training. In this episode, I am going to wrap up my mini-series on some of the new views that have been added to the ranges library in C++23 by talking about chunk. Now, I of course do encourage you to check out the video description for links to t-shirts, Patreon, various ways that you might support this channel. This episode is sponsored by Undo. Do you spend far too much time debugging? Did you know you can cut your debugging time by 50 to 80% with a technique called time travel debugging? Undo offers a full time travel debugging solution for C++ applications. Visit undo.io to see how it works. Undo provides a free trial at the link below for you to play with the tech and explore some of the features of time travel debugging. You can get started in 2 minutes and save yourself days on diagnosing the root cause of complex bugs like race conditions, sig faults, memory corruption, Stack Overflow errors, and more. Okay, I'm going to start right up with the example that I had from the last episode, and we're going to look at chunk. The point of chunk is that it also returns a sliding window of ranges of references to the elements. So we can chunk in groups of 3, but let's be clear, it is not actually a sliding window, I should clarify, like we were getting from slide and adjacent before. Now it is chunking it up into groups of that size. So we have 1, 2, 3, comma, 4, 5, 6 printed, which should raise a couple of questions for you. Now, first of all, what happens if I try a size that is not evenly dividable by the number of elements in my container? And chunk does not have any problem with that, which is presumably one reason why it is not returning a tuple, because it needs to be able to handle unfilled chunks. So really, that's all there is to it with chunk. Now, I will just go ahead and take a minute to show you that there has been a lot of things that were added to ranges in C++23. We briefly covered so far enumerate, zip, mentioned zip transform, adjacent view. We did not mention adjacent transform, but I think you get the idea. We have not talked about join, but we have talked about slide and chunk. And then we have chunk by, which is interesting, splits the view into subranges between each pair of adjacent elements for which the given predicate returns false. That is effectively a split, is it not? A view over the subranges obtained from splitting another view using a delimiter. Very similar concept. And then similar is stride, which skips elements. It is going to skip the number of elements that are passed in to the view. These things are all very nicely composable, and I am sure you can find a good place for them in your code that currently works with containers of things once you have the opportunity to in your C++23 ranges code. So thank you for watching this episode of C++ Weekly. This one was particularly short, but I hope you enjoyed it, and be sure to subscribe.